Hi all, in today's lecture, we will learn about the number of trailing zeros, right? But before learning about number of trailing zeros, we will solve few questions, probably one or two questions, right? In yesterday's lecture, we have learned how to find the number of factors, how to find the number of even factors, how to find the number of odd factors, how to find the sum of the factors of a number, right? So before switching to the subtopic number of trailing zero, try to solve this question, try to answer what is the number of factors. You will have to prime factorize 56, 36 and 42, right? Like you will have to write 42 equal to 2 into 3 into 7. Similarly, you will have to write 436. Similarly, you will have to write 456. Means at all the bases there should be prime numbers 2, 3, 5, 7, 11, 13. Then you will look at the powers, you will add plus 1 in each power, and then you will multiply, and then you will get the number of factors, right? Try to solve this question. We will have to write 56, 228, 214, 2 into 7, right? Means 56 equal to 2 into 2 into 2 into 7. Means you can write 56 as 2 cube into 7 to the power 1, right? 2 cube into 7 to the power 1 and to the power 20. Then you will write 36 as 2 into 18, 2 into 9, 3 into 3. Basically, 36 equal to 2 into 2 into 3 into 3 into 3. So 2 square into 3 square. So you can write 36 as 2 square into 3 square to the power 31, right? Then you will write 42 in this way, 2 into 21, 3 into 7. So 42 equal to 2 into 3 into 7. Right? Means you can write 2 into 3 into 7 to the power 13. Then obviously you will have to write 13 as 13. 13 is already a prime number. We can't prime factorize 13, right? So you will have to write 13 to the power 21, right? Now tell me, what will be the power of 2 in this case? What will be the power of 2? 60, right? The power of 2 will be C. You will have to remember this formula. A to the power m into n. right? So 2 to the power 3 to the power 20 into 7 to the power 1 to the power 20, 2 to the power 2 to the power 31, 3 to the power 2 to the power 31, then 2 to the power 13, then 3 to the power 13, then 7 to the power 13, and then 13 to the power 21. Any doubt till now? Right? Now 2 to the power 60, 3 into 20 will be equal to 60, right? Then you will have to write 7 to the power 20, right? Then you will have to write 2 to the power 62. 2 into 31 will be equal to 62. See, why did we break 56 as 2 to the power 3 into 7 to the power 1? Why? Because when do we apply that formula of number of factors? When you look prime numbers at all the bases. See, 56 is not a prime number, right? That's why you can't directly apply that formula. So 2 to the power 60 into 7 to the power 20 into 2 to the power 62, 3 to the power 62, 31 into 2, right? Then 2 to the power 13, then 3 to the power 13, then 7 to the power 13, then 13 to the power 21. Why did I bring this question? Such that if you get this kind of tweaked questions in the examination, you must be able to solve this question. Now 2 to the power 60 into 2 to the power 62 into 2 to the power 13, right? Do you know this formula? A to the power m into a to the power n equal to a to the power m plus n, right? Means we can write it as 2 to the power 60 plus 62 plus 13, right? Are you able to get this thing, right? Into, let us look at 3 to the power 62 plus 13, then you will have to look at 7 to the power 20 plus 13, then you will have to look at 13 to the power 21, right? Now 2 to the power 60 plus 62 is 122, 122 plus 13 is 135, right? So 2 to the power 135 into 3 to the power 75 into 7 to the power 33 into 13 to the power 21. Now we can apply that formula of number of factors. Notice that these are prime numbers, right? So what will be the number of factors? Number of factors will be equal to, we have solved so many questions of this concept, 135 plus 1 into 75 plus 1 into 33 plus 1 into 21 plus 1. See, you will not get this kind of linear calculation, but if you get, there are high chances that you will be able to answer by just looking at the unit digit, right? See, in examination, obviously you will not get this kind of linear questions such that you will have to multiply these numbers. But see, what is this number? 136 into 76 into 34 into 22, right? 6 into 6 will be 36. 36 into 4 will be 144. Into 2 will be 288. Means at unit place 8 will come. See, we don't have to find the exact number. Why? Because in examination, obviously, we will not get this kind of lengthier values, right? But yeah, if you look at this question is testing your basic concepts. That do you apply 20 plus 1 into 31 plus 1 into 13 plus 1 into 21 plus 1 into Rus? Right? So if you apply that formula directly, you will lose your marks. But even if you don't multiply, you will have idea that 8 will come at unit place. Maybe if you get 4 options, only one option will have 8 at unit place. Are you getting this point? 6 into 6 means 6 will come at the unit place. 6 into 4 means 4 will come at the unit place. 4 into 2 means 8 will come at the unit place. So there are high chances that if you get this kind of lengthier questions, there will be only one option that will have 8 at its unit place. Means you will not have to multiply these numbers to get the exact answer. Any doubt? Okay. Now try to answer this question. Obviously, we haven't solved this kind of questions earlier, but try to think about this question for 1 to 2 minutes. Every day, I bring a different question. Except that kind of concepts that we learn in everyday lectures. What is given in the question? The number of boys in a class is 3 times the number of girls. Okay, let us assume that number of girls in class is P. See, you can assume it as X also, P also, Y, K, whichever letter you are more comfortable, right? So we have assumed that number of girls in class is equal to X, and in the question it has been given that number of boys in a class is 3 times, means number of boys will be 3 times of the number of girls. What is the number of girls? X. So 3 into X. So the number of boys will be 3X. Any doubt till this point? Now read the question. The question says, which one of the following numbers cannot represent the total number of children in the class? Or you can say total number of students in the class, right? So what is the total number of children in the class? Simple, X plus 3X, that is equal to 4X. Are you able to get this point? That this is the number of girls, this is the number of boys. So total number of children in the class will be X plus 3X, that is equal to 4X, right? Now you have to answer that which one of these 4 numbers cannot represent the total number of children in the class. So let us check each number. Okay, if total number of children is 40, means basically 4X equal to 40, means X equal to 40 by 4, right? Means X equal to 10, right? Yeah, this means number of girls is 10, means number of boys will be 3 into 10 will be 30. Okay, means 40 can be the total number of children in the class. We have checked about it. Now let us look at option B, that says 44, right? So 4X equal to 44. Now we are checking about option B, right? So X will be equal to what? 44 divided by 4, means X equal to 11, means 11 is the number of girls, and 33 is the number of boys. 3 into 11, that is equal to 33. Means we have checked about option B. Yeah, option B can be the total number of children in the class, right? Now let us look at option C, that is 42. If 42 is the total number of children in the class, means 4X equal to 42, means x equal to 42 by 4. So 2 into 2, 2 into 21. So x equal to 21 by 2, that is equal to 10.5. Means 10.5 is the number of girls. Can we say that thing? Can we say that thing? That 10.5 is the number of girls? We can't say that thing, right? Are you able to get this point? See, whenever you get this kind of question, that which one of the following numbers cannot represent the total number of children in that class, see, if you practice a number of questions, you will have idea that total number of children in the class will be multiple of 4. 40 is the multiple of 4, 44 is the multiple of 4, 48 is the multiple of 4. Means 42 is not multiple of the 4. Means you must be able to answer option C correctly and quickly. But if you are not able to think in that way, then what to do? Then the question arises that if I am not able to think in that way, then what to do? Okay, let us deal with each options one by one. Right? When we dealt with option C that says that the total number of children is 42, we found that the value of x is 10.5. Option C is saying that the number of girls is 10.5. Is it feasible? Number of girls can be 10, 11, 9, 12, can be a complete number. Can we say that 10.5 is the number of girls? You can't say that thing, right? Means 42 can't be the total number of children in the class. So 42 is the correct answer. So if you solve this kind of question, so tell me, is this question really difficult? No, we haven't solved this kind of questions earlier. Or even if we have solved this kind of questions earlier, we haven't tried to develop our basics, that how to approach this kind of questions, right? Okay, any doubt in this question? See, even if you deal with option D, 48 means 4x equal to 48 means x equal to 48 by 4, right? So x equal to 12. Yeah, 12 is the number of girls and 36 is the number of boys. Means option D can be the total number of children in the class, right? So option C is the correct answer, right? Any doubt? Any doubt? Okay. Now we will learn about trailing zeros in today's lecture. So what are trailing zeros? If you read the line, trailing zeros are the zeros at the end of a number. Trailing zeros are the zeros at the end of a number. So if you look at 2500, see, there are 2 zeros at the end of 2500, right? So there are 2 trailing zeros, right? If I take a simple number 750, tell me what is the number of trailing zeros? 1. Only 1 zero. See, don't look at these lines for now. Only look at this line and this line for now, right? So if I say 750, what is the number of trailing zeros? 1. If I give you a simple number 1000, what is the number of trailing zeros? 3. Right? Trailing zeros are the zeros at the end of a number, right? If I give you a simple number 2250, what is the number of trailing zeros? 1, right? There is only 1 zero at the end. So 1 is the number of trailing zeros in 2250, right? We will come to this line later, that the number of trailing zeros in a number depends on that there are how many pair of 2 and 5 in that number. We will come to that thing later. Don't get confused with that word. For now, remember this line and you can note these simple examples if you want to note. Okay, let us start learning more about trailing zeros. Let us look at 100. We can write 100 as, if you prime factorize 100, what will you do? 2 into 50, 2 into 25, 5 into 5, means you can write 100 as 2 into 2 into 5 into 5, means you can write it as 2 to the power 2 into 5 to the power 2. Okay, 2 to the power 2 into 5 to the power 2. Now let us break 2500. See, you can, obviously you can prime factorize 2500 in this way, but you will have to invest a lot of time. Are you able to get my point? You will have to write 5 into 125, 5 into 25, 5 into 1, then 5 into 1, right? You can prime factorize 2500 in that way. But can you write it as 25 into 100? Yeah, we can write it as 25 into 100. What is 25? 25 is 5 to the power 2. 25 is 5 to the power 2. 5 to the power 2 means what? 5 into 5, right? And can you write 100 as 2 to the power 2 into 5 to the power 2? See, 100 is equal to 2 to the power 2 into 5 to the power 2, right? So we have written 100 as 2 to the power 2 into 5 to the power 2, right? So basically we can write 2500 as 2 to the power 2 into 5 to the power 4. Why 5 to the power 4? 5 to the power 2 into 5 to the power 2 will be equal to 5 to the power 2 plus 2, that is equal to 5 to the power 4. Or even if you are not able to think in this way, you should be able to think by looking at the prime factorization of 2500, that is equal to 2 to the power 2 into 5 to the power 4, right? So basically 2500 is equal to 2 to the power 2 into 5 to the power 4. Why are we prime factorizing these 3-4 numbers? Why? Because the goal is to learn about the number of trailing zeros. Once we prime factorize this number, then I will show you some kind of relationship between number of trailing zeros and the powers of 2 and 5, right? So can we write 7000 as 70 into 100? Can we write 70 as 2 into 5 into 7? 2 into 5 is 10, into 7 is 70, right? And can we write 100 as 2 to the power 2 into 5 to the power 2, right? So can we write it as 2 to the power 3 into 5 to the power 3 into 7? See, 2 to the power 1 into 2 to the power 2 will be equal to 2 to the power 3, and 5 to the power 1 into 5 to the power 2 will be 5 to the power 3, right? If the base is same, means we are adding powers, right? So 12,000, can we write it as 120 into 100? So let us prime factorize 120. 2 into 60, 2 into 30, then 2 into 15, 3 into 5. So basically we can write 120 as 2 cube into 3 into 5, right? And 100, we can write 100 as 2 to the power 2 into 5 to the power 2, right? So we can write it as 2 to the power 5 into 5 to the power 3, and obviously into 3. See, 2 to the power 5, 5 to the power 3, and into 3. We have prime factorized 100, 2500, 7000 and 12,000. Right? Now read this line. The number of trailing zeros is determined by the lesser of the powers of 2 or 5. Means if you prime factorize some number, look at the power of 2 and 5. Look at the power of 2 and 5. Whichever power is less, pick that power as the number of trailing zeros. Like look at the prime factorization of 100. 2 to the power 2 into 5 to the power 2. So the power of 2 is 2, the power of 5 is 2. So in this case, both powers are same. Both powers are same. Means you can't pick lesser one. Means you can pick only one power, that is 2. And look at the number of trailing zeros, that is 2. That is 2. Okay, we will take another example, then you will be able to learn more. Let us look at this case. Look at the power of 2 and 5. The power of 2 is 2 and the power of 5 is 4. So obviously the power of 2 is less. And what is the power of 2? The power of 2 is 2. That's why the number of trailing zeros is 2. Right? Now look at this case. Let us look at the power of 2 and power of 5. But fortunately both powers are same. So obviously means the number of trailing zeros should be equal to 3. Look at The number of trailing zeros is 3. Right? Now let us look at this case. Let us look at the power of 2 and power of 5. So the power of 2 is 5 and the power of 5 is 3. So which power is less? Obviously the power of 5 is less. And what is that power? That is 3. So what is the number of trailing zeros? Number of trailing zeros is 3. Are you able to get this point? Means whenever you get any number, you can prime factorize that number. You can see, if you directly get the number, why will you prime factorize? If you get 12,000, if I ask you that what is the number of trailing zeros, you will directly answer 3. If I give you a random number 7,000, if I ask you that what is the number of trailing zeros, you will directly answer 3. But suppose if you get this kind of expressions, where there is some power of 2, there is some power of 5. You only have to look at the power of 2 and the power of 5. And whichever power is less, you have to pick that power as the number of trailing zeros. Any doubt? Hopefully you are able to understand. You can note this number. Sorry, you can note this line. The number of trailing zeros is determined by the lesser of the powers of 2 or 5. Or you can, obviously, you can also note this line, that minimum means you have to take the minimum of power of 2 and 5. If luckily power is same, you can take that power as the number of trailing zeros, right? Any doubt? Okay, obviously, we will solve many questions related to this concept such that you will be able to apply this concept in those questions. Okay. Now, try to solve this question and try to think that how will you apply that concept in this question. Sorry. I will give you one hint. You can write 8 as 2 to the power 3. Right? You can write 15 as 3 into 5. Means 3 to the power 1 into 5 to the power 1. You can write 25 as 5 to the power 2. You can write 22 as 2 to the power 1 into 11 to the power 1. And then you will look at the power of 2 and 5. Okay. Everyone should try to solve this question. Don't worry, try to put 2, 3, 4 minutes to solve this question correctly. Try to apply that concept that we have learned for now. Okay. Okay, let us start solving this question. See, you can write it as 8. You can write 8 as 2 into 2 into 2 means 2 to the power 3, right? Then you can write 15 as 3 to the power 1 into 5 to the power 1, or you can say 3 into 5 simply, right? Then obviously 23 is already a prime number, so you can't prime factorize it anymore, right? Then 17, then you can write 25 as 5 to the power 2, right? 5 to the power 2 equal to 25. Then 22, so obviously you can write it as 2 to the power 1 into 11 to the power 1, right? 2 into 11 is 22. Then 23 is, okay, 17 is here, sorry. Okay, 23 is here and 23 is again there. Okay, 23 is again there. So into 23 to the power 1, obviously, or even you can't write, you can skip writing to the power 1 and 37. Now we only have to look at the power of 2 and the power of 5, right? So what is the power of 2? See, 2 to the power 3 and 2 to the power 1. So basically this is equal to 2 to the power 3 plus 1, right? 2 to the power 3 and 2 to the power 1. So what is the power of 2? That is 4, right? And obviously we can skip thinking about any other number except 2 and 5. Let us look at 5. So 5 to the power 1 and 5 to the power 2. So basically 5 to the power 1 plus 2, and you can write it as in this way. So what is the power of 2? The power of 2 is 4. And what is the power of 5? The power of 5 is 3. So which means the power of 5 is less, right? And what is the power of 5? 3. So 3 is the number of zeros. 3 is the number of zeros at the end of the product. Means 3 is the number of trailing zeros. Someday they will write find the number of trailing zeros. Someday they will write find the number of zeros at the end of the product. Means at unit place 0 will come, at tens place 0 will come, at hundreds place 0 will come. Then obviously there will be some number from 1 to 9, right? That's why we are saying that there are only 3 zeros at the end. Means what? That means this number, the number who is at this place will be from 1 to 9, right? Means there will be 3 zeros, right? See, if you solve this kind, if you practice a number of questions related to this concept, obviously you will not write so much, right? After some practice, why will you write so much? You will not write so much. You will only look at 8 and you will think that, okay, this is 2 to the power 3. Then, okay, 15, yeah, there is 3 into 5. There is 3 into 5. But why we will write about 3? That is wastage of time, right? In 15, there is 1 5, right? Then, okay, there is no 2 or 5, there is no 2 or 5, but in 25, there is 2 5. So 5 to the power 2. Then you will look at 22, means 2 into 11, means there is 1 2, 2 to the power 1 in that case, and there is no 2 or 5 in 23 and 37. Then you will look at that what is the power of 2? The power of 2 is 4, right? The power of 2 is 4. And what is the power of 5? That is 3. Means the power of 5 is less and the power of 5 is 3, means the number of trailing zeros is 3. Means the number of zeros at the end is 3. Hopefully you guys don't have any kind of doubt related to this question, right? Okay. Now try to answer this question. See, this question is a linear question. 2, 4, 6, 8, 10, and then 12, 14, 16, 18, 20. But don't worry. Try to solve it. Then obviously we will solve it together. Or I can give you one hint in this kind of question. Look at the, okay. All of you should try for 1 to 2 minutes. Then I will share that approach. That how do we solve this kind of questions quickly. if you look at these numbers, you will find 2 in every number. Are you able to get this point? You will find 2 in every number. See, 2 into 1, there is 1, 2, right? There is, again, you can see that there is present, 2 present in this number. Again, you can notice there is 2 present in this number. Again, you can notice there is 2 present in this number, right? Means, again, you can notice that there is 2 present in this number. Again, you can notice that there is 2 present in this number, 2 to the power 2 into 3. But why will we think about 3? Right? We don't have to care about 3. So, are you able to notice one thing? That there is 2 present almost in there is 2 present in every number. Right? So, obviously, the power of 2 will be higher. So, we only have to look at the power of 5. Now, try to solve this question. That the power of 2 is going to be higher than the power of 5. Why? 2 is present in every number, right? Means you only have to look at those numbers which contains 5. And 5 will be in which number? 5 will be present in 10. 5 will be present in 20. If you look at further, you will find that 5 will be present in 30. 5 will be present in 40. 5 will be present in 50. Means you have to think about 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140 and 150. Two is present in every number. So the power of 2 will be higher than the power of 5. So only think about the power of 5. Twenty-two, 24. Okay, okay, okay. Everyone should try to answer that. What is the number of zeros at the end of this product? What is your answer? Okay, 19. Okay. Okay, everyone should try to answer. It doesn't matter whether you get it correct or incorrect. We are in the learning phase. So we have freedom to do a number of mistakes before the CSAT exam, right? Okay. Okay, let us start solving this question. See, 5 will be present in 10, 20, then 30, then 40, then 50. Are you able to get this point? Are you able to get this point? See, 5 is not present. 5 is present in 10. Then 5 is present in 20. See, you can't write 18 as a multiple of 5. You can't write, right? Then 5 will be present in 30. So 5 is present in 10, 20, 30, 40, 50, 60, 70, 80, 90, then 100, then 110, then 120, then 130, then 140, then 150, right? So in 10, you can write 10 as 2 into 5, right? So basically there is 1 5 in 10. You can write 20 as 2 to the power 2 into 5 to the power 1. 2 to the power 2 will be 4 and 4 into 5 will be 20. So there is 1 5 in 20. You can write 30 as 2 into 3 into 5. 2 into 3 is 6. 6 into 5 is 30. So there is 1 5 present in this case. You can write 40 as 2 to the power 3 into 5. 2 to the power 3 will be 8. 8 into 5 will be 40. So there is 1 5 in 40. And look at 50 carefully. 2 into 5 square. 5 square is 25 and 25 into 2 will be 50. So there is 2 5 in 50. Right? Then there is 1 5 in 60. You can write 60 as 5 into 12. Right? In 12 there is 2 to the power 2 into 3. But in 5 there is 1 5. So 5 to the power 1. You can write 70 as 5 into 14. Means 5 into 2 into 7. Means there is 1 5 in 70. Right? Then you can write 80 as 5 into 16. Means 5 into 2 to the power 4. Right? So there is 1 5 in 80. Then you look at 90. You can write 90 as 5 into 18. In 18 there is no 5. Right? 2 into 3 square will be equal to 18. And into 5 means there is 1 5. Then look at this number carefully. 100 is equal to 2 to the power 2 into 5 to the power 2. 2 to the power 2 will be 4. 5 to the power 2 will be 25. So basically there is 2 5 in 100. There is 2 5 in 100. Are you able to get this point? Right? Now 110. You can write 110 as 5 into 22. In 22 there will be 2 into 11. And in 5, so there will be 1 5. You can write 120 as 5 into 24. In 24 there will be no 5. So there will be 1 5 in this case, 5 into 24. Then you can write 130 as 5 into 26. See, you can solve this question. You should solve this question again at your home if you don't get it correct. Right? So 5 into 26 means there is 1 5. Right? Again 140 you can write it as 5 into 28. So there is 1 5. Then again this is there is, see, 150 equal to 25 into 6. 6 is 2 into 3. So there is 2 5. 25 means 5 to the power 2. Now we will have to add all the powers. So 1 plus 1 will be equal to 2. 2 plus 1 3. 3 plus 1 4. 4 plus 2 6. Plus 1 7. Plus 1 8. Plus 1 9. Plus 1 10. Plus 2 12. Plus 1 13. Plus 1 14. Plus 1 15. Plus 1 16. Plus 2 18. Did we do anything wrong? Okay. No. It may be that there is not a single correct option. It can be. Right? See. Sorry. Okay, see 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 25 into 6, 5 into 28, 5 into 26, 5 into 24, 5 into 22, 5 squared, so 25 into 4, 5 into 18, 5 into 16, 5 into 40, 5 into 12, 25 into C. So 1, 1, 2, 3, 4, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 18 will be the correct answer. Okay, okay. Okay, sorry. 52, 54. No, there is no 5. There is no 5 in 52, 54. Right? There is no 5. So 18 will be the correct answer. We can make C as 18. Right? Which number did you count more? Because you answered 19. Which 150? 150 is equal to, you can write 25 into 6. Right? So this is 5 to the power 2 into 2 into 3. Right? So 18 is the correct answer. So what is the number of trailing zeros? What is the number of zeros at the end of the product? That is equal to 18. Any doubt? Hopefully, see, our goal should be to learn the approach, right? See, in examination, there is very less chances that you are going to get the exact question. But if you learn the approach, you will be able to apply this approach on that question, right? So basically, what does this question teach us? This question teaches us that in this kind of questions, when you see some linear calculations, there are chances that you will have to ignore at least one's power. See, in this case, we found that 2 is present in each case. 2 is present in each case, right? That's why we were able to ignore the power of 2, right? That's why we were able to ignore the power of 2, right? Means we only had to look at the power of 5, right? And we knew that 5 will be present in these numbers. 5 will be present in these numbers. So what is the correct answer? 18 is the correct answer. 18 is the number of zeros at the end of the product, right? Now try to answer this question. What is the answer? 5. Okay. What is everyone's answer? Okay. Okay. See, 20 is equal to 4 into 5, means 2 square into 5 to the power 1. 2 square into 5 to the power 1, right? So basically, you can write 20 as 2 square into 5 to the power 1, right? Then in 15, there is 1 5. In 15, there is 1 5. Although we can write it as directly 3 to the power 1 into 5 to the power 1, but there is 1 5 in 15, right? Then let us come to 16. So there is 2 to the power 4, then 44. So you can write it as 2 to the power 2 into 11 to the power 1. See, you can skip writing 3 11, right? Because we have to save our time. Why we will write 3 to the power 1 and 11 to the power 1? We know that in 44 there is 2 2. 2 2 will be 4. 4 into 11 is 44. Now 72. So you will write 72 is equal to 8 into 9. Means 2 cube into 3a square. Although you can skip writing 3a square. Right? Then 95. So basically 5 to the power 1 into 19 to the power 1. You can skip writing 19 to the power 1. Right? Then 25. So 5 to the power 2. Right? Now let us look at the power of 2. The power of 2 is 2 plus 4 6. Right? Plus 2 8 plus 3 11. So what is the power of 2? That is 2 to the power 11. Right? Then let us look at the power of 5. So 1 1 2 1 3 and then 5. Right? And then there are so many numbers, but we don't have to think about those numbers. So the power of 5 is less. And what is the power of 5? The power of 5 is 5. So 5 is the correct answer, and 5 is present in option B. Right? So option B is the correct answer. Hopefully everyone is able to understand that how to approach this kind of questions when we get some numbers in the multiplication form. Right? Now tell me, if you get those questions in the form of factorials, then what should be our approach? Right? So now we will learn trailing zeros in factorials. That how do we approach those questions when we have to deal with some kind of factorials? See, did all of you have learned factorial earlier, or is there anyone who has no idea about factorial? Okay. See, if I say 5 factorial, the meaning is simple. 5 into 4 into 3 into 2 into 1. Means start with 5, then get till 1. If I say 9 factorial, means simple. 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Are you able to get the meaning of factorial? This is the basic concept related to factorial. We don't need to learn more than this thing, right? When it comes to factorials in this chapter. Okay? Means if I say 11 factorial, means 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Right? Okay? Now, if I give you this number, see, forget about 7 factorial. If I give you this multiplication, that tell me what is the number of trailing zeros in 7 into 6. See, forget about 7 factorial. Don't think about 7 factorial. If I ask you that what is the number of trailing zeros in this product, 7 into 6 into 5 into 4 into 3 into 2 into 1, what will be your answer? 1, only 1. See why? The power of 2 is 2 to the power 2 and 2 to the power 1. So the power of 2 is 3, but the, see, again 2 is also present here, right? So the power of 2 is 4, but the power of 5 is 1. So the power of 5 is less. The power of 5 is less. So basically 1 is the number of trailing zeros in this product. 1 is the number of trailing zeros in this multiplication in this product. Hopefully you are able to get this idea that we have learned it earlier. Now this value is equal to 7 factorial. We also know that 7 into 6 into 5 into 4 into 3 into 2 into 1 is equal to 7 factorial. Right? Means the number of trailing zeros in 7 factorial is equal to 1. Right? Okay. But this is a smaller multiplication. That's why you are able to observe. But if I give you 101 factorial, then 101 into 100 into 99 into 98, do we have so much time? right? That's where we will have to learn the approach, that how to deal with those questions when it comes to factorials to find the number of trailing zeros. So what is the approach? The approach is very simple. If you have been asked to find the number of trailing zeros in 7 factorial, means you will simply have to divide 7 by 5. You will have to divide 7 by 5. So tell me, if you divide 7 by 5, what will be the quotient? The quotient will be 1. The quotient will be 1, right? And the remainder will be equal to 2. But here you have to write only quotient, right? See, divisor, dividend, quotient, remainder, right? Hopefully everyone has that basic idea. So what will be the quotient? The quotient will be 1. So tell me, can you divide 1 by 5? No. You can't divide, see, okay, you can divide 1 by 5, but you will get value in decimal, right? But you can't divide 1 by 5, right? You can't divide 1 by 5. So 1 is the number of trailing zeros. So 1 is the number of trailing zeros. Now look at 19 factorial. So again, simple, 19 by 5. 19 by 5 is equal to 3. Can you divide 3 by 5? No, you can't divide 3 by 5, right? You can't divide 3 by 5. So what is the number of trailing zeros? 3, right? Now let us look at 34. 34 factorial. Now you will divide 34 by 5. What will be the quotient? 6. 6 will be the quotient. But now 6 is divisible by 5. 6 is divisible by 5, right? And if you divide 6 by 5, the quotient will be 1. Are you able to get this thing? That the quotient will be 1. So what is the number of trailing zeros? 6 plus 1, that is equal to 7. Means if you have been given 34 factorial, or if you have been given any n factorial, to find the number of trailing zeros, you just have to divide that number by 5, right? And you can, then you will get some quotient. If the quotient is not divisible by 5, you will have to stop at that point. See, in this case, we stopped at this point. 1 is not divisible by 5. In this case, we stopped at this point. 3 is not divisible by 5. But in this case, when you divided 34 by 5, you get 6. But 6 is divisible by 5. So you divided 6 by 5 and you get quotient 1. But now 1 is not divisible by 5. So we didn't, right? But we added these values. 6 plus 1, that is equal to 7. So 7 is the number of zeros in 34 factorial. 19 factorial, the number of zeros is 3. In 7 factorial, the number of zeros is 1, right? Any doubt? Okay, we will again solve few questions to solidify our concept that we have learned for now. Now try to answer this question. Okay, everyone should try to answer this question. And don't worry, if you don't get it correct for now, all of us are in the learning phase. What is the answer? 18. Okay, let us see that what is the correct answer. Okay, let us start solving this question. We have to answer what is the number of zeros at the end of 89 factorial. So simply we will have to divide 89 by 5. If you divide 89 by 5, you will get 17 as quotient. Are you able to get this point? You will get 17 as quotient. Then you will divide 17 by 5. So you will get 3 as quotient, right? Can you divide 3 by 5 anymore? No, you can't divide. So what is the number of zeros? Means simply 17 plus 3 equal to 20. Where did you do wrong? अच्छा कोई बात होता है. Okay, so 20, don't worry. 20 is the number of trailing zeros at the end. Okay. Any doubt in approach, that how do we approach this kind of questions? Okay. So 20 is the number of trailing zeros. 20 is the number of zeros at the end. Right. Now try to answer this question. Okay. Okay. Okay, let us start solving this question. Again, we will divide 123 by 5, right? And if you divide 123 by 5, okay, let us divide it here. Sorry, 5 into 2, then 2, then 3, 5 into 4, okay, means the quotient will be equal to 24. Okay, we can divide 24 by 5, right? If you divide 24 by 5, let us divide 24 by 5. So 5 into 4 is 20, means the quotient will be 4. Can we divide 4 by 5? No, we can't divide anymore, right? So what is the number of trailing zeros? What is the number of zeros? Simple, add these two values. 28 will be the correct answer, and 28 present in option D. 28 present in option D. Any doubt? Now try to answer this question. Okay. Okay. Find the number of zeros at the end of 1000 factorial, right? So simply we will have to divide 1000 by 5. Okay, let us divide 1000 by 5. So 5 into 10, then obviously it will be 00. So 200, right? The quotient will be equal to 200. Can we divide 200 by 5? Yeah, we can divide it. 200, if you divide 200 by 5, you will get 40 as quotient, right? Can we divide 40 by 5? Yeah, if you divide 40 by 5, you will get quotient as 8, right? Can you divide 8 by 5? Yeah, the quotient will be equal to 1. The quotient will be equal to 1. So can you divide 1 by 5? No, you can't divide. So 200 plus 40 plus 8 plus 1, the answer will be equal to 249. See, the options are very close to each other, right? So in examination, if you get this kind of easier question, you don't have to do mistake at any cost, right? Because these questions you will have to solve these questions correctly. See, in out of those 80 questions, they definitely ask few easier level questions, right? So at the beginning, your goal should be to identify those easier questions and solve those questions correctly. Then our goal should be to identify, see, while going through those questions, our goal also should be to identify medium level questions. That, okay, I will not attempt these questions at the beginning, but let us mark these questions, right? That I will come back to these questions again, right? And obviously, you should definitely skip few questions. Why we will invest our those precious 2 hours time to solve each question, to read each question, right? When our goal is to crack CSAT, right? There is not any kind of relative cutoff. right? In prelim there is related cutoff. Okay, if so many students scored so much, then the cutoff will go higher, right? But in CSAT there is not any kind of that kind of issue. So the correct answer is 249. Okay. Now try to answer this question quickly. Again, we will have to divide 23 by 5. If you divide 23 by 5, what will be the quotient? The quotient will be equal to 4, right? The quotient will be equal to 4. Can you divide 4 by 5? No, you can't divide, right? So, what is the number of trailing zeros in 23 factorial is 4, right? Now, let us look at this kind of questions. So, okay, tell me what is the trailing zeros in this number? Try to answer this question. That what is the number of zeros at the end, or what is the number of trailing zeros? What is the answer? 3. Okay. 1. Okay. Okay. If you are not able to think directly, let us think in this way. 3, there are how many zeros? 3, 3, 6. Okay. 6 zeros. Then 7, 5 zeros. 1, 2, 3, 4, 5 zeros. 7, 5,000. Okay. 40,000. So basically 4 zeros. So 40,000. Then 90. If you add these numbers 0, 5, 4. Now let us look. What is the number of trailing zeros? 1. Only 1 zero is present at end. Right? After that 9 is there. So you can't count this 0. The number of trailing zeros will be equal to 1. But think one thing, that will we write numbers in this way to answer? No. We will not write numbers in this way. Then we will add. It will require some time, right? Still you can do some kind of silly mistakes. You can do some kind of error in counting the number of zeros, right? So whenever if you get this kind of simple questions, look at the minimum number of zeros in the end. That is 90. The minimum number of zeros. So means 1 is the number of trailing zeros, right? Suppose if I add plus 7 in this number, means the number of trailing zeros is 0. Are you able to get see? Till now there was only 90. So the minimum number of trailing zeros was 1. The minimum number of trailing zeros was 1. So the answer was 1. But if I add plus 7, now the number of trailing zeros in this is 0. Number of trailing zeros in 7 is 0. So now the minimum number of trailing zeros is already 0. So the answer will be 0 in that case. Are you able to get that point? Okay. Now try to answer this question, or if anyone likes to share the approach, that how will we approach this kind of questions. Now try to recall this thing. See, basically in this question I told you that look at the minimum number of trailing zeros. That will be your answer. Listen this line carefully. Look at the minimum number of zeros, minimum number of trailing zeros, right? So again there is sum. If you look at the question carefully, there is basically sum, right? Basically you will have to find the number of trailing zeros separately. Then the minimum number of trailing zeros will be your answer, right? Now try to answer this question. Treat each number separately and find the number of trailing zeros. 25 into 48 into 75. Try to find the minimum number of trailing zeros. Okay, 2 is the answer. Okay. Okay, let us start solving this question. If you look at 32, in 32 there is basically 2 to the power 5, right? 2 to the power 5 is equal to 32. In 20, there is 2 to the power 2 and then there is 5 to the power 1. 2 to the power 2 is 4 into 5 is 20. And in 30, you can say 30 is equal to 2 into 3 into 5. 30 is equal to 2 into 3 into 5. So there is 1 2 and there is 1 5, right? So now what is the power of 2? Power of 2 is 8. The power of 2 is 8 when you look at this number, right? And what is the power of 5? The power of 5 is 2. The power of 5 is 2. So what is the number of trailing zeros? In this number will be equal to 2. Why? The power of 5 is less. And what is the power of 5? The power of 5 is 2. Okay, the number of trailing zeros in this part is 2. Let us look at this part. 25 into 48 into 75, right? But you should be, see, okay, I will share that trick in the end. 25 into 48 into 75. So in 25 there is 5 to the power 2. There is 5 to the power 2, right? In 48, 48 is basically 2 to the power 4 into 3 to the power 1, right? So there, okay, let us skip writing multiplication. There is 2 to the power 4 in 48. And obviously we will not write 3. Why we will write 3? It will waste our time. And in 75, 5 to the power square into 3 to the power 1, right? But we will not write 3. So what is the power of 2 is 4. What is the power of 5 is 4. Means both powers are same. So what is the number of trailing zeros in this part is equal to 4. Okay. Let us look at 200 into 125. In 125 there is 3 5. In 125 there is 3 5. Let us think about 200. 200 is equal to 25 into 8. 25 into 8 means 5 square and 2 to the power 3 means 2 to the power 3 and 5 to the power 6. The power of 2 is less, means the number of trailing zeros is equal to 3, right? Now let us look at 10 into 40. 10 into 40, 2 to the power 1 and 5 to the power 1 and 2 to the power 3 into 5 to the power 1. So what is the power of 2 is 4, and what is the power of 2? What is the power of 5? That is 2. So obviously the power of 5 is less. So the number of trailing zeros is equal to 2, right? So see, the number of trailing zeros is 2. The number of trailing zeros is 4. The number of trailing zeros is 3. The number of trailing zeros is 2. So what is the minimum number of trailing zeros? 2. So the correct answer is 2. But I will suggest you one thing. Suppose you calculated for the first part. Suppose you calculated for the first part and you found that the number of trailing zeros is 2. Let us look at option. Options are 2, 3, 4, 5. Means already we have brought 2. If there is any trailing zero that is less than 2, there should be one option that says 1. But 1 is not there. But 1 is not there. Are you able to get this point? Means you should mark option A quickly, right? Or if you look at the last part, 10 into 40 is 400. Even if you are not able to think in that way, 400 has 2 trailing zeros, right? Means the number of trailing zeros will be equal to 2. And is there any option which says 1? No, there is not a single option. So why we will invest our time anymore, right? So we will have to be smart by solving a number of questions, right? Okay. So hopefully all of us learned something new in today's lecture. Did all of you enjoy today's lecture? Okay. Okay, then let us connect in the next lecture. Okay.